My name is Kevin Burry. I work at Aquacut. You guys are working on a DXF file for us to cut titanium with. We use the DXF file to upload it into our program, which gives us a template of how we're going to cut your part out of titanium with water and abrasive, it's called. We load it into the computer right over here. This is a makeshift part of what we use for Lakeland. It's 30 thousandths. We cut, it takes around 4 minutes to cut for these two parts. This part right here is probably around 31 inches long by around 10. Now if you come on over here, this is the main cutting table. There's only so much of a range that actually you can use because there's actually inside here, there's actually trip sensors, and if it goes too far to either way, X or Y, it'll trip and shut off so you don't damage the part or anything like that. Right here we have this is the high pressure line, just bringing in the water from the pump room. Right over here we have the garnet. This is our garnet hopper. And it feeds down in the tube down here. From the water, it comes into this chamber in here called a mixing chamber, which is a piece right here. This is a mixing chamber. On the top here, there's a piece called a jewel, and it's like has a 10 thousandths hole in it. And inside here is where the garnet will be feeding in, and on the bottom is another hole, which is where the mixing tube, which is this piece on the machine here. That rests on here and it's be mixing the water and the garnet at the same time. And it's a 10 thousandths jewel with a 30 thousandths hole mixing tube.
And what's the garnet for?
The garnet is to help actually cut the material. There's a large variety of materials we can cut. Some of them we can actually cut with just water, but most of it we need garnet because it actually gives it like sandpaper. It gives it the cut of edge to pretty much sand away your part, sand away the cut line. Gives you your part. All right, let you know there's the way we determine the speed of our cut is actually based on thickness. Like in a CNC or a mill or anything, you actually have a chart to use. This one actually, the program is all Windows based, so you actually have a program that already has it built into it. If you watch me real quick, I'm going to be going change path, and this is where we're going to be loading up your program into here under your company, your high school's name and everything. But down here, this is where we have the list of all the materials that we cut, and if you see the numbers right next to it, that's the speed that we cut them at, which gives it the different speed. Like if say we go to metal, right here stainless steel, which is at 80 versus what I was doing, which is 643, a big variance in speed. Regular mild steel, which is what we usually do for normal steel, like hot rolled and cold rolled steel. Different thicknesses, doesn't matter what thickness is, but adding a different thickness will add different times. Say if I went an inch, that's 21 minutes now for this type of part with mild steel. So it all depends, for us it's all based on the thickness and what type of material. It depends on our speed and also how much time it takes to cut it. The machine runs pretty much the same as a CNC, but the only difference is that some CNCs have a Z-axis where this one only has an X and Y axis. And I'm going to actually start the machine up and you can actually watch me cut one of the parts I'm doing.
And why do you have to hold that down like that?
I have to hold it down because the water pressure causes it to push up the Lakeland.
And it's really thin material?
Yeah, 30,000 Lakeland. if it pushed up, the hole would not cut right.
So I see, so it's blasting a hole in the center of the hole, and then it's cutting from there.
Yes.